extra practice on compound inequalities, we're going to do just a couple quick examples after we review what and or statements mean. Real quick, an and statement over here means we have -8 is less than some number x, and x is less than some number 2, which means that we need to make both of these statements true by picking a number. So the number 0 would fit between both of these statements. Also, the number -5 would fit between both these statements. We can graph that by making an open circle at -8, because there is no equal sign part here, an open circle under 2, and we are going to shade between these two numbers because we want to be greater than this number but less than this one. And so any number that you pick in here, like 0 or -5, would make both of these statements true. An or statement, by contrast, means that we need to make either one of these statements true. So either or means that we can do either of them. So for example, if I have a number that has to be less than the number 4, that means any number that's in this shaded portion would make both of these statements true by definition. Then, if this has to be greater than or equal to -6, close circle, also any number that's here. So for an or statement, the only thing that doesn't make this true is anything in between them. So in a lot of ways, and statements and or statements should look opposite when they're graphed on a number line most of the time, not 100%. For solving and statements, in this case, because these two statements are together, we can make this into an and statement. This would be the same thing as splitting up the middle to both sides. So this would be a true statement. And also, this would be a true statement. And I could solve both of these equations, and I could make the and statement from that. But in the last video, we talked about we can also just solve these simultaneously by doing a double equal sign here, which means, well, let's try redrawing that line. That didn't go so well. Which means that if I do something to the middle, I have to make sure I do it to both of the outside. So the first step would be to subtract 4 from every part of this equation. That makes this -12. The middle is just -2x, and the right is -4. And the signs are going this direction. From here, I need to divide everything by -2. And I'm hoping that you'll notice, because I'm dividing by a negative, I have to flip all of the inequality signs. So it becomes 6 is greater than or equal to +1x, which is greater than or equal to +2. And a good way to check to make sure that I'm doing the right steps so far is to remove the middle and see if you make a true statement. In this case, 6 is greater than 2, so I'm probably correct up to this point. To graph, I want to make a closed circle at -6, because there is an equal sign part down here. And make a closed circle at +2, because there is a part equal sign here. And I'm going to shade between these numbers. Therefore, anything in the middle should make this statement true. For example, if I picked x equals 4 and plugged it into the top equation, it should make a true statement. So -8 is less than or equal to, this would be -2 times 4 plus 4 should still be greater than 0. This is -8. -8 plus 4 is -4. And that is a true statement. So, and statements can be solved a bunch of different ways, but when you're done, you're usually looking for a shading that is between your two solutions. Or statements are a little bit trickier in this situation because there is not a nice shortcut to be able to solve them at the same time. So we're going to have to solve both equations, but separately. For the left equation, we are going to do the distributive property, which gives me 3x plus 12 is greater than or equal to 9. I'm going to subtract 12 from both sides, which gives me 3x is greater than or equal to negative 3. I divide everything by 3 to get x is greater than or equal to negative 1. I can then shade that by making a closed circle at negative 1 and shading everything to the right. And that means what I'm hoping for, if I solve this correct, is a number that is going left, probably somewhere in this region. So let's see if we did it right. I'm going to draw the line down the equal sign here, right there. And I'm going to add 8 to both sides, which gives me negative 4x is greater than or equal to positive 8. I'm going to divide everything by negative 4. I see a dividing by a negative sign here. So that means x has to be less than or equal to, because I flipped the sign, negative 2. So closed circle at negative 2, shading left. And that means I very likely do have this correct. Just like I talked about in the last video, I am going to help you learn to check these answers, but it is very difficult to do that by hand, efficiently at least. So we are going to be learning a new strategy to check them as a class. As always, if you have any questions, make sure you let me know.